Hello everybody and welcome to a new episode of Coding with Alex. Today I will show you how to apply a model ViewModel pattern in SwiftUI. But first, let's take a look at the final application. For this demo, I've created a very simple app where you can find music searching for artists. As you can see, the search button is enabled or not according to the text written in the text field, and the progress view appears when needed during the loadings. Before we start, please remember to support me subscribing to my channel. Very well, let's start a brand new project for our demo. Before start coding, allow me to explain what is the MVVM pattern. Using a simple diagram, we have three components in this pattern: the view, the model, and the ViewModel. The view will be responsible to create all the UI widgets and presenting them on screen. The model will hold all the original data that will be displayed somehow on the screen. The ViewModel, on the other hand, will be responsible for all the business logic and to manipulate and transform the data from the model in order to present it somehow on screen as needed. Each component knows about the other components following these rules. The view holds an instance of its ViewModel and can talk directly to it. The ViewModel, on the other hand, talks to some view using bindings, but it has no idea who it is. In a similar way, the ViewModel holds an instance of its model. The model talks to some ViewModel using bindings, but it has no idea who it is. Please note that, according to this diagram, the view and the model can never talk to each other. Back to coding. The first thing is to create the models of the responses. For the only service needed in this app, I've used the free version of the iTunes APIs. On their website, you can find all the info you need to use their services. I tried to search something and I had the JSON response that I'm about to show you. As you can see, the response is made up by two fields: result count, an int, and an array of result objects. In the result objects, we will find a lot of infos, a lot of types, a lot of fields, but we only need just a few of them, just like the track name, the artwork, or the price, or the currency, and the track ID. So first thing first, let's create the objects of the response. Working with SwiftUI, it's the best practice to create an example static var to use in the previews. In order to avoid to ship it to production, add an if-debug conditional statement. Few errors were made during the coding of the models. We can fix them at this stage very easily. Let's start to create our home view and recall it in our content view. But first of all, let's create the main view model of our application. As stated before, the view model talks to the view using bindings. To create a binding, our view model must conform to the observable object protocol and have one or more published objects. Every time a published object is modified, it sends a message to the subscribing entity, in our case, the view. The view, on the other hand, using a state object property wrapper on the view model, will refresh its body, updating all the displayed data. We will need few published properties: a results array with the response of the search, a search text string typed by the user. I'm adding a property observer here that did set closure, and soon we will see why. Then we need a bool to enable or not the search button according to the value of the search text. And another bool to control the progress view for the loading. The characters of the search text enable or disable the search button. It's time to code the only service required by our application. We will use the new async await APIs from Apple, and then we'll decode the response using a standard JSON decoder. Since we are updating the UI, remember to bring everything back on the main thread. For the sake of simplicity, in case of error, I will simply print an error message. It's now time to work on the home view. The view will hold an instance of the view model, declared as state object, in order to force to update the body of the view when the published objects in the view model are modified. As seen at the beginning of the video, the UI is really simple, just a text view with a loading and a button, and eventually a list that will display the results of the search. The text field is bound to the ViewModel search text property. The progress view is hidden or shown according to the value of the isLoading variable in the ViewModel. The same behavior is given to the button. It will be shown or hidden according to the value of the isSearch-enabled property in the ViewModel. And in the same way, the whole button is disabled according to the value of the isSearch-enabled property in the ViewModel. It's time to create a view for the search row. If you remember what I said at the beginning, the view and the model cannot talk to each other. The view will talk only with the ViewModel. I know that it's quite common to feed a row with a model of the displayed item, but it is not the canonical way to apply an MVVM pattern. So let's create a ViewModel for this view, able to wrap the search result item that will be shown on the screen. As you can see, different properties are combined together to create a full price property string. Let's use the newly created ViewModel to finish our view. The search result example that we have created at the beginning of our project is used here for the preview. We can use the new powerful async image to download the image from the net. And now back to our main view, and we will use our created row. As you can see, we created a view model and we give it to the search result row. Let's add the navigation title and the application is finished. If you like this video and you want to support me, please subscribe, or even buy me a coffee, or follow me on Medium. All the links are in the description of this video. See you!